Now I'm going to explain for question 3. For question 3a, it's already given f xyz equals to this equation and phi equals to xyz square. First, we have to find what is the value of nabla.f. Nabla.f equals to nabla f, which is we have to differentiate f respect to x plus f respect to y plus f respect to z. And then we get 2z plus 1 plus y square. Second, we have to find nabla cross with f. We have to use the cross rule, and then we get 2zy minus 2z, 2x, and 0 in this form. Third, we have to find nabla dot nabla phi. First, we have to find nabla phi, which is we have to differentiate phi xyz square respect to x, y, and z, and then we will dot with nabla, which is we have to differentiate again. We have to differentiate this respect to x, respect to y, and respect to z, and we will get 0, 0 to xy. For 4, we have to find nabla times with nabla.f, which is nabla.f we already got from the first question. We can take this answer, and then we times with nabla, which is we have to differentiate this in bracket, and then we will get 0, 2, y, and z. In question 3b, we have to find unit normal vector at the surface given, which is x cubed y minus y squared plus z squared equals to 7 at this point, which is p equals to 1, 2, 3. First, we have to find the vector of f, which is x cubed y minus y squared plus z squared minus 7, and then we dot with nabla, and we get this. And then we have to substitute the point given into this equation, and then we get 6, negative 3, and 6. So from here, we can find the magnitude of nabla f at that point, which is equals to 9. And to find the unit normal vector, we have to use this formula, and then we substitute the value, and we got unit normal vector equals to 2 over 3, negative 1 over 3, and 2 over 3. For question 3c, it's already given that the maximal directional derivative of f, which is df over ds, is at point 1, negative 2, 4 is equal to square root of 52. And then it is attained the direction from P towards Q, which is this is the point of Q, and we have to find nabla f at point 1, negative 2, 4. So in the question said that the direction is from P towards Q, which is we have to subtract Q with P, and then we get that the direction is 3, negative 4, 1. And then we have to find the magnitude, and we can find the unit normal vector. So we know that df over ds is equal to nabla f dot with unit normal vector. Df over ds given is 52, and then nabla f is equal to lambda times unit normal vector dot with unit normal vector, and then we have to substitute all the value that we got from here, and we will find the value of lambda. So we know that nabla f is equals to lambda times with unit normal vector u, and then we can substitute the value, and we got that nabla f is equal to 3 square root 2, negative 4 square root 2, and 1 square root 2. Next is question 4. So for question 4, we have to evaluate this equation, which is C is curved parametrically as x equals to cos t, y equals to sin t, z equals to t with limit 0 to 2 pi. So first we have to differentiate x, y, and z, and then we have to find ds. So ds is equal to square root 2 dt, and then we can substitute all the value into the equation, which is the limit is 0 until 2 pi, and then ds, we have to change it with dt, and then we will get negative 2 square root 2 pi square. For question 4b, we have to find a work done of force given. This is the force given. F equals to xzi plus y 2yj minus 3xk. And then from 111 to 222 for line segment 1, and from 222 to 341 for line segment 2. The curve given is x equals to 2 plus t, y equals to 2 plus 2t squared, and z equals to 2 minus t cubed. First, we have to find line segment 1, which is C1. V, we can find by subtract second point with first point, which is 2 minus 1, 2 minus 1, 2 minus 1, and then we get 1, 1, 1. And then we have to find x, y, z with formula x equal to x naught plus at, y naught plus bt, z naught plus ct. So x naught is equal to the first point, 1, 1, 1, and a, b, c is equals to the direction. And then we can get x equal to 1 plus t, y equals to 1 plus t, and z equals to 1 plus t. Then from this, we can get the limit, which is dt is equal to 1, 0 to 1. We have to find r. So r, we have to write x, y, z in vector form, and then we have to differentiate it respect to t. So for total work done, we know that the formula is integration of f dot dr. So f is already given, and then dr we already find it. Substitute the value, and then we will get that total work done for line segment 1 is 5/6. Then for line segment 2, also same, we have to find the direction, which is we have to subtract point 2 with point 1, and then we get the direction is 1 to negative 1. And then x, y, z is already given from the question, which is the curve. So x equals to 2 plus t, y equals to 2 plus 2t squared, and z equals to 2 minus t cubed, which is from here we can find the limit of dt, which is 0 to 1. And then we can write this x, y, z into vector form, and then we will differentiate it respect to t, and we get that dr equals to 1i plus 4tj minus 3t squared k, and then we substitute all the value into the equation. We integrate, and then we get that total work done for line segment 2 is 491/20. So total work done for both line segment, we have to add, and then we will get that total work done is 25.3833. Next, for question 4c. The question asks to find this one, where phi equals to xy minus y squared z, and then the path is joining at point 1, 0, negative 1, and 2, 1, 1. So we have to find nabla phi, which is we have to differentiate phi respect to x, y, z, and then we have to find the direction, which is 2 minus 1, 1 minus 0, and 1 minus negative 1, and then we can find the x, y, z with formula x naught plus at, y naught plus bt, z naught plus ct, and then the value that we got, we can use value of y, we can use it to find the limit of dt, which is 0 to 1. And then we have to write this into the vector form to get r, and then we differentiate towards t, respect to t, and then we get 1i plus 1j plus 2k. And then we can evaluate the integration, which is we substitute the value that we already find, and we'll get that it is equals to 1. Next, for 4D, we have to evaluate this equation by using Green's theorem. So the point C is from 0, 0 to 2, 0 to 0, 2 to 0, 0 in direction of counterclockwise. So we can sketch it, and we got this. From here, we can find the limit of dx and dy. And then from Green's theorem, we have to find Q and P, which is the first one is P and the second one is Q. So we have to differentiate it. For P, differentiate respect to y, and Q, differentiate respect to x. And then we substitute into the Green's theorem, and then we substitute all the limit, and we solve it. So we got that it is equals to 0. So for question 5, we have to evaluate this equation, which is part of the surface of cylinder given, which is cylinder is equal to x squared plus z squared equals to 4, and it is the first octant between y equals to pi and y equals to 4. So first we have to sketch the cylinder, and the limit for y-axis is pi to 4. And then we have to find the shadow, from the shadow here, we got that dy, the limit is pi to 4, and then the limit for ds is 0 to 2. Then we will arrange the equation to get zx and zy. We have to find ds in terms of dA. And then we substitute all the value given, the value that we have already find into the equation to evaluate it, and we will get the answer is 32/3 in bracket 4 minus pi. So for the 5b, we have to evaluate this equation by using Gauss theorem, which is Gauss theorem is equal to triple integral of nabla dot f dv. So f is already given in the question, and it's already given the equation of hemisphere, which is 8z equals to 4 minus x minus y square root of 4 minus x minus y square at plane z equals to 0. And then first we have to find nabla dot f, which is we will get it 2x, and then we have to sketch the hemisphere and find the shadow to get the limit of d delta, d phi, and d rho. This we can refer to note of chapter 3 in triple integral. So we can use that we can substitute all the value into this triple integral, and then we get the answer is 0. For equation 5c, we have to evaluate the integration of f dot dr by using Stokes theorem, which is Stokes theorem is equal to double integral nabla cross product f nabla cross f dot with n, and then in the question it's already given the value of f in vector form, and then the equation for hemisphere that lie above plane z equals to 1. First, of course, we have to sketch the hemisphere first and find the shadow. From the shadow, we will get the limit, which is dr. The limit is 0 to 2, and d theta, the limit is 0 to 2 pi. And then we arrange the equation to get the phi, which is phi equals to x squared plus y squared plus z squared minus 4. And then we have to differentiate phi respect to x, respect to y, and respect to z. From here, we will find the magnitude, and then we get the unit normal vector, which is nabla phi divide with the magnitude. So to find nabla cross with f, we have to find it using cross formula, and we get 0, z, 0. And then we arrange the equation to find zx, zy, and find ds over dA. So we'll get that ds is equal to 2 over z dA. Next, we have to substitute all the value that we find just now into the Stokes theorem, and we solve it. We got that the answer is 0. So, thank you.